Here on 14.6, and this is page 865, we have the idea of object conversion, and I don't want to belabor the point here any. We are accustomed to type conversion from previous chapters where we could have an integer, and where we know that integer is going to need more specificity in the way of decimal points, we can cast an integer as a double type. You'll actually recall in chapter 12 with structure, we did that casting with some of our objects as well, structures rather, as well. So the idea that we can do that with an object here based on a class, I think it just follows suit. So what we're saying here is that we can convert the type of something into the type of something else. So here on, again, this is 865. In the code sample, you'll see that we have a class called feet in inches, and we have a distance associated with that. And that distance is an integer distance. But you and I both know that integer for distance is totally inadequate, right? If I have a wall here, so I'm painting this wall over here. This is a true story. That's why all this extra garbage is back here behind me. I don't have any space. And I need to paint this wall here too. If this wall turns out to be 16 feet, that's great. But the chances are it's not going to be 16 feet 0.00, right? It's going to be 16 feet and some change. So rather than looking at feet in distance as an integer, we are supposing here in the example that it would be more valuable to look at it as a decimal. So what we have is a double conversion for our integer class type. And you can see that down here. We've got our operator for double, and this is on page 865. And this would simply go into the feet inches header. The operation we have here is just the double with the, the parens there that says cast this as a double. And what you'll see is we are taking double temp equals feet. So that feet refers back to our class, feet inches. Then we have the assignment of that as a double, and we return the double. So then, boom, we can use that return value as an assignment for, in this case, a double variable that we're using in our main. Why might this be of value to you? Well, there's tons of reasons why this might be of value to you. If we are working with an integer, say, for a balance for something, is it possible that you could have integer only for an account balance? Probably not, right? But it would behoove you to be able to cast that as a double occasionally so that you have the exact specificity you need to be able to get the job done. Maybe you are looking at distance, again here from the example, as an integer because you were really just feeding it in as part of, how many feet is this? Great, let's change that. Let's be more specific. First we were working with how many feet is it here in a room. That's not the biggest deal when we're working with paint. You can overestimate or underestimate that by a little and probably you'll get there. But if we're working with like celestial differences, that ain't gonna cut it. The difference between 1.3 light years and 2 light years is the difference between getting you home and stranding you in space forever. So we can cast an object as a different type the same way that we could do when we did it in 12 with structures, and the same way we did it in chapters 5 and 6 when we did it with cardinal primitive data types.